The first technique we're going to use is the shift and share technique. It's very interesting to use this technique to see what in the region has really a competitive advantage and what sectors in the region really do not have a competitive advantage. And the industries that have a competitive advantage, you may consider extending those sectors because you after making this analysis, you are going to conclude that this region is so good at this sector. Shift and share analysis is a technique for dividing an area's growth into three components. So here's the formula. Delta EI. EI is local employment in industry I, beginning of the period. EI star, on the other hand, which is going to be here, is local employment in the industry I at the end of the period. So there are two types of variable. Those without a star reflect the level of the variable in the beginning of the period, and those with a star reflect the level of the variable in the end of the period. For instance, local employment, let's say that it changed in 2 years from 100 employees to 300 employees. So that will be 100, there will be 300. Now this is local, little e is local. Then the other type of variable you have is the US levels. It is the same thing. If it has a star, it's the end of the period. If it doesn't have a star, it's the beginning of the period. So this, without a subscript I, it just means total overall employment in US. This is in the end of the period. This is in the beginning of the period. Here, it's employment in US, but in that industry I you're talking about, for instance, agriculture. That will be the end of the period, beginning of the period. So those are the four variables we have here. Little e means local, US means US level, I means the industry such as agriculture or manufacture, and if you don't have any subscript, it means overall levels in the economy. Before we continue, I wanted to explore this formula a little bit. The first thing I would like to emphasize about this formula is that this equality here is valid for the simple reason that all the terms here will cancel out until all that you're going to see here will be delta EI. Basically, what am I talking about? I am going to use the distributive rule here and multiply EI by US star over US. That's overall employment in US in all the sectors together and beginning. And then using the distributive here, that's going to be minus EI. I'm going to do the same thing here. That's going to be EI, employment in US in the sector in the end of the economy and in the beginning, minus EI here. I'm going to use the distributive again. EI, US, overall level of employment end of the period, beginning of the period. Now I'm going to use the distributive again here. This is EI, EI star over EI, minus EI, US star, USI. What can you see here? Well, notice that this is the same as this. So they cancel out, one minus the other. Also notice that this is the same as this. So they cancel out. What's left over is this EI here minus plus this term here. Notice that this part cancel out with this part. So what's left over is EI star. Now, changing places here. This is level of employment in the end of the period minus level of employment in the beginning of the period. But that's just a definition of delta EI. So basically, this equality here is valid. I created this decomposition, but I did not change the variable I'm talking about. I am talking about here about change in employment. What I want to do is decompose this change in employment into these three parts here, because they're going to help me to analyze the strength, the competitive strengths of the region. Now, another thing that I wanted to emphasize is that all the terms in brackets represent percentage terms. Let's start with the first one here, the first bracket. Okay? Notice that instead of 1, I'm going to write total employment in US divided by total employment in US. Why can I do that? Because those one divided by the other is going to be 1 anyway, so I'm not changing anything. But then now using algebra, I can put these two in the same denominator. So that is US level of employment in the end of the period minus in the beginning divided by in the beginning. That is the definition of a percentage change. Okay? For instance, if US employment changed from 200 to 300, how would you calculate the percentage change? The final level, 300, minus the level in the beginning, 200, divided by the level in the beginning, 200, that's 0.5, which is the same as 5 divided by 10, which is the same as 50 divided by 100, which is the same as 50%. Those three numbers here are all the same. You're just expressing the same thing in different notations. 0.5 is the same as 50%. Okay? So this term in here is a percentage change. That's the percentage change in overall employment in US. Now, consider the other terms. This is the percentage change of overall employment in US. If I include a 1 here, or a minus 1 here, and if I include a minus 1 here as well, notice that this minus 1 will cancel out with this minus 1 because minus times minus will become plus. So this minus 1 will disappear. But now each term looks exactly like this term. It's also a percentage term. This is the percentage change of employment in US in sector I, and this is the percentage change of employment overall in US. So let's say that this is 20% and this is 30%. Let's say that I is agriculture, that's the sector. If this is 30% and this is 20%, I'm going to say that agriculture grew up 10% more than the rest of the economy in US. So again, if this is 20%, which is the overall increase in employment, and this is 30%, which is the overall increase in employment in agriculture, I'm going to say that agriculture grew 10% more than the rest of the economy. That's going to be this term in bracket here. And finally, this is the percentage growth. Again, I added the minus 1 here and I added the minus 1 here just to emphasize that this is a percentage term. I'm not changing anything because this minus 1 will cancel out with this minus 1, which will become plus. But this is the percentage change in, say, agriculture in the region, and this is the percentage change in agriculture in US. So if this is 40 and this is 10, let's say that agriculture in the region grew 40% and in US it grew 10%. This is going to be 30. What is this, 30%? It means that in the region, agriculture grew 30% more than in the rest of the country. Okay, now that I made some points about the formula, let's go back to the slides. Now let's go back to our example when we are talking about the agricultural sector. I invented some numbers here, so I am assuming that the number of employees in agriculture in the region I am studying increased from 100 to 150. So the increment in employment was 50. Again, that's agriculture and that's in the region I am studying. Now let's look at each term of the decomposition. First, I am assuming here that the US economy as a whole increased by 30%. If that's the case, of this 50 increment in employment, 100, which is the initial level of employment, times 30%, which is 30 of these new jobs occurred just because the U.S. economy grew as a whole. So that is the national growth component. Now think about it. If the U.S. economy is growing as a whole, it's going to consume more agricultural products. So production of agricultural products will have to increase. So that's going to require more jobs, just because of the fact that the nation as a whole was growing. Now let's look at the second term. An area may grow faster than the national average if it has a disproportionate level of employment in industries that grew fast nationwide. So this is the overall growth in US, and this is the overall growth of agriculture in US. It's measuring how much faster agriculture is growing than the other sectors. Times 100, which is the initial employment in the region, that's also 30. So 30 jobs were generated in the region just because that region specializes in agriculture, and agriculture is a dynamic sector at the moment. Notice that those 2 percentage changes here, they are in national level. So I am measuring the competitiveness of the industry all around the country, not necessarily the competitiveness of the agricultural industry in the region. This is just a dynamic industry at the moment. This is called the shift mixed component. And finally, let's see the third one. This is the growth of agriculture in the region minus the growth of agriculture in the country. You can see that this term is negative. Why? Agriculture grew faster in the country than it grew in the region. So I'm assuming the differences in percentages is minus 10. So minus 10 jobs were created in the region because the region is less competitive than in US. So adding up the terms, 30 plus 30 minus 10, of course I have 50. What do we want from this decomposition? The number of jobs in agriculture grew. Did this number increase because this region is specially suited to produce agricultural products? No. The last component here is measuring the competitive advantage of the region compared with other areas because of positive externalities, because of environmental issues, etc. This is the so-called regional component. And you can see that agriculture is growing less in the region than US, so the region is not specially suited to the production of agriculture. In fact, because of the regional component, the number of jobs actually decreased, not increased. So that is maybe the most important part of the decomposition. That is measure the region suitability for the product, which should reflect again any positive externalities, any regional competitive advantage in the sector. And in this example, it is actually negative. So jobs went up, not because the region is especially good at agriculture, but because agriculture grew up in the country. There are some exercises here. You, as practice, should try to replicate this row here, and that will be the exercise presented in class. Use this data to substitute here in the formula and try to go ahead and try to replicate these numbers here. So we can practice how to calculate the composition, and you also have the answer so you know if you're right or wrong.